I think the people who are really building share great insights and it's super valuable. And then people who are just saying these buzzwords and it's so surface level, you know that they're not really building. And we've been building.
Yeah.
And we think about agents a lot and it's moving fast, but we're pretty dialed in on it. So yeah, there's a lot to talk about and share. Like I could honestly go on for days about this.
Hi, everybody. Welcome to another YAAP episode. And today I'm here with Dean from Tavily to talk about AI agents, evals, and their latest deep research tool. Hi, Dean. How's it going?
I'm doing great. Thank you for having me.
It's really great having you here in reInvent. Thank you, AWS, for this studio. Dean, what brings you here?
So we're here to be with the ecosystem, engage, learn about agents, and find our ecosystem partners.
Oh, I think that Tavily, you exists for several years. I remember that you released some sort of open source in 2023, if I remember correctly.
GPT researcher.
Yeah, which was, I think, one of the first agents or agent-like tool use that we've seen in the ecosystem. And recently, you got a lot of hype on the deep research tool that you had. Right? Can you maybe tell a bit about it?
Yeah. So for the last year, I've been working very closely with customers to understand what exactly they're building with Tavily. So trying to find like a repeatable pattern that customers are implementing. And we've noticed that like 90% of use cases converge on this topic of research. So
when you say research, give me an example of a use case or a prompt.
So this could be market research, company research, people research, financial research, medical research. So the list goes on, but a core knowledge work task is doing research. And what that means is going to the internet, finding information, synthesizing it, summarizing it, and performing some analysis, and then getting like a high quality output. So information that's valuable to the end user.
Okay.
So, and based on this observation that everyone's building research agents, we decided to release our own API, which is research or deep research out of the box. So this is the latest offering, and we also noticed that the lift to build this type of agent is quite high. So a lot of enterprises just want the ability to connect to deep research without having to go through this process of building, optimizing, and maintaining, which is why we've released this API.
Yeah. And you said work as an FDE, which is a field deployment engineer.
Right.
So,
yeah, forward deployed engineer. So the idea is we work very closely with the customers throughout the life cycle, before the sale, through adoption, and we embody the persona of our end user, which is an agent builder. So since we're a tool, the tool is being used in a larger system, and the FDEs are experts on building AI solutions and AI agents so that we can empathize with the customer, work directly with them, and help them get faster time to value.
Yeah, this is something that we've seen as well at AI21. This is why we have like such a big solutions team, because even though, right, it's never been easier to build with LLMs or like MCPs, standardized tool calling, still requires a level of expertise that usually you don't have in every company. And not every software engineer wants to work on those things. Right. So we do see a lot of people asking, right, for those type of. And so you said you work with a lot of companies. You've seen that they need deep research, and you release this API.
Mm-hmm.
I know it's in beta right now, but can you maybe share something on how you built it, how it works, what happened there?
Yeah. So Our journey for building this endpoint was actually like a 7-month journey. And the whole nature of building agents has changed drastically even in 7 months. And so we attempted building a research agent in the summer, and we had to redo everything from scratch because the models have changed significantly. And as models change, the system has to change, or like the agent harness. The way that the models connect to tools changes. So there's this co-evolution between the harness or the system, the model, and the tools. And since it's changing so drastically, the task is, how do you build software around rapidly evolving models? And we have learned a lot of lessons throughout this process. In our second go around, we felt very confident learning the lessons from our first failure, which I could share in more detail. And we landed on an architecture that we are very confident in. And
So just to make sure, when you say architecture, this is an entire system that I'm just giving a prompt and maybe some sort of, I don't know, requirements or like the models I can use or something like that, or
yeah.
And it just handles everything for me?
Yeah, so the inputs are, first is your research task, which is just a natural language prompt describing what information you want. You also have the choice of our mode, agent mode or model. So we have our mini and our pro version.
So this essentially means how much I'm willing to spend.
Yep. It means the depth of research and the latency, the cost, and the underlying capability of the agent is slightly different. So the pro agent is more of a multi-agent system, and the mini is a single agent system. So we took a slightly different technical approach. And then we have auto. So depending on the user's query and the complexity, we will automatically set whether mini or pro should be used. So there's the mode, there is the input, which is the research input. And then there's the ability to obtain different forms of output. So different citation formats like MLA, APA, Chicago, numbered citations. There is structured output. So maybe you don't want markdown output, but you want like a structured JSON schema. And then another parameter that we've added is MCP servers. So
I can connect whatever MCP servers I have to that system?
Right. So if you have a remotely hosted MCP server, you could pass in a list of those remotely hosted servers, and then the agent will operate slightly differently and will connect into the server as well as the publicly available web data to provide like a hybrid research experience.
Can you give an example of an MCP server you've seen someone uses?
So GitHub MCP, maybe you want to do research on to find job candidates or job applicants, and you want to understand what they're doing on GitHub, but also what they've posted online, if there's anything about them on the internet. So you could do research, like that's like profile research or candidate research. You could do Notion MCP, Mongo, any internal search to combine proprietary company data with public data to give like the full context and scope of research.
Okay, that's cool. And right now you said you were in beta, so you're building with several clients.
Right, yeah. We're currently getting feedback from customers. So like we'll talk about evals, but the most important eval is the customer experience.
Yeah.
So we're iterating with them, working on a tight loop. That's the current status.
Cool. And you mentioned eval, so maybe let's talk about that. I think that what catched my eye when I've seen the latest release was that you scored #1 in the DeepResearch benchmark.
Mm-hmm.
Was this something you were optimizing for, or was it something that, like as part of the process, it just aligns with all the the things you already wanted to achieve?
Yeah, so we were not optimizing for it. And in fact, we were not, throughout the development process, we weren't running this eval. We just ran it at the end. What we were optimizing for is like production quality behavior. And one of the number one components there is like latency, reliability, and token consumption. And being number one on DeepResearch Bench is great. It's like a big achievement. We're proud of it. But what's even more impressive to us is the token consumption and the efficiency. And I'll provide an example. So one of the top solutions on the benchmark, like a widely known open source, is LangChain's Open Deep Research. It's amazing, inspired us and taught us so much about how to build agents. Through the full DeepResearch Bench eval, it consumed around 200 million tokens. Our state-of-the-art run consumed around 70 million tokens.
Less than a half.
Yeah, so crazy efficiency. And to us, that is more significant than a couple % bump on a benchmark. And the fact that we were able to achieve both is also really interesting. It kind of shows that if you can remove, there's so much noisy tokens within like a full agent run. And if you can remove them and somehow figure out how to retain all the useful tokens but remove the noisy ones, then you can actually achieve better performance at a lower cost, lower latency, better token efficiency. So yeah, that was super important to us, and also reliability. So limiting failure modes.
When you say limiting failure modes, what do you mean?
So deep research agents a few months ago maybe would last a couple minutes. Now they're lasting up to several hours even. If you look at deep research or like long-running agents, a couple of months from now, a year from now, we're thinking like 10-hour execution period. And as the time horizon increases for these agents, the number of failure modes also increases exponentially. There are so many different failure modes in a long-running software system like this, and we need to implement many guardrails. We need to detect anomalies to make sure that the behavior is as expected throughout the process, so that you don't get surprised by some like horrible output after 10 hours. So there's all these different guardrails we implemented to reduce or limit failure modes. And this is super important. As agents get longer and longer, I see this as like a main challenge for building agents.
Yeah, I think waiting 10 hours and getting some shit responses like want to break the computer. You know, it's funny. I was expecting a totally different answer about the benchmark, and I had like questions line up in my head about that. But I'm actually more interested right now to maybe pick your brain a little and see what you can share about what did you do, because you said you optimized for production grade, and that's like a great buzzword.
Yep.
But what does it mean? I always talk about eval-driven development. Right? This is something that not just me, right? Everybody talks about it these days, when we talk about LLM development. But how do you actually do it when it comes to agent?
So, is the question how did we approach building these production grade agent, and like what does that mean concretely?
Yes, whatever you can share.
Yeah, so as I mentioned, a heavy focus was on limiting token consumption or token efficiency through context engineering. So when we're hosting an agent as an API, latency, cost, token consumption, and failure modes is what we paid most attention to. Concretely, how you do that is a lot of trial and error, a lot of close monitoring of agent traces. So, like literally reading the agent trace and making sure it's behaving as expected, constantly finding more and more failure modes and building in these anomaly detection or safeguards. Fallbacks is a huge thing. So there are several possible errors. With every tool you have, every LLM call you have, there's the potential for rate limiting, some issue with that external service you're using, and we need to have fallbacks, we need to have safeguards in place. So we want like reliability. That's what I mean when I say production grade. And I know it's a buzzword.
Yeah, everybody's saying reliability. I think that the word trust is, I've seen it like 100 times in the expo alone.
Yeah. And the biggest irony of the production grade buzzword is that it's used mostly in scenarios where the agent isn't in production or will never go into production. But if we're hosting an agent as an API, by definition, it's in production, and we need to serve our user base, which is large, so it needs to actually be production ready.
So I just want to maybe ask a bit about you mentioned context engineering, which I'm guessing is the main part of cutting down a lot of the tokens.
Yep.
So any maybe tips or insights that you can share rather than just make it only 50% of the context window?
For sure. And we published a blog with some details on how we did this, so I'm able to share some insights. So data you retrieve from the web is high in volume. If you think of like a search tool within an agent, it could be doing many searches concurrently. Each search could have 10 results. Each result could have many, many tokens. So even within one tool call for search, there's many tokens, like it's high token volume. And compared to other tools, web search is even, like it's significant. So we need to find ways to limit exposure of those tokens to LLM calls throughout the process where we can. And the main area we did that is in the tool calling loop. So our agent architecture was very biased towards simplification. And we learned that through the original attempt where we overcomplicated things.
This is the failures that you mentioned before?
Exactly. So we have a very simple architecture which involves tool calling in a loop, like it's a common pattern.
Yeah.
The question is, what information does that tool calling LLM have exposure to at every run or at every turn of the agent? And if we provide it access to the web search results at every turn, and it's iterating constantly on the single agent level and the multi-agent level, sounds
very wasteful.
Yeah, it's a quadratic token consumption. And if you're able to distill that web data into some lower token representation, then you can save significantly and actually make it a linear consumption as iterations increase.
Just by cutting some of the, let's say, web page results, or?
So we're not cutting anything out. We're just representing it in a different way.
That's even more interesting.
Yeah.
Do you have any more details in the blog? Should I go check it out?
Yeah, exactly. So there's only so much I can share there, but if you take tons of web data, the tool calling model wants to know what it has seen previously, but it doesn't need to know every single detail of what was on the web page. So if we can provide some summarization or some distillation of those tokens and provide that to the tool calling LLM, then it's totally capable of making an informed decision on which tool to call next without seeing all the tokens. So if you extend this to the single agent layer, the multi-agent layer, we save a tremendous amount of tokens. That's one technique. The second is like deduplication. So for web search, you're often retrieving redundant URLs. at the single agent layer and the multi-agent layer. Imagine your multi-agent spawns many research agents in parallel. And then it does this sequentially, and the same URLs are being retrieved. We don't want those tokens to ever be consumed. So we have to do source deduplication on the single agent layer and the multi-agent layer, global and local deduplication. Another way to reduce redundant token consumption.
I think it's really cool. This is how you really distinguish from the people who are just, I think, just talking about building agents and the one who actually build agents. And these are maybe not the most fun parts to look at, right? But it's important, nonetheless.
Yeah. So the task is like reading the agent traces as you're building and saying to yourself, is all the information being fed into this LLM call necessary, or can we compress or transform it in some way where the whole idea is there, all the information is present, but we can minimize or chop out some tokens. And then you're going to want to hold on to that information, that web content for later on and reintroduce it.
Yeah, so you have to implement some sort of memory, I guess.
You could call it memory. You have to persist some state over time and store that information somewhere and reintroduce it later on in the agent's architecture. The way you could think about it, if you're in the LLM state of mind, is like a residual network, like a ResNet connection. So you can store that web data and just like pass it around later on in the architecture.
It doesn't have to go through all the layers, just somewhere along the way.
Yeah, later on when you're going to want to, write out the final report or write out some intermediary steps, you'll reintroduce. That's where the residual connection will be reattached, but you don't need to pass it through every node.
Yeah, so it's really like there are stuff that are not as important, so we could ditch it, and there are stuff that are important, just not for every step of the way.
Right.
So,
and the naive approach to context engineering for tool calling is taking all messages, so that's tool calling message inputs and outputs, human messages, AI messages, and passing all of that information in to the tool calling LLM at every run.
So it won't miss a thing, I guess. Well, I can kind of understand that, right? You call it the naive approach for a reason. You don't, like you say maybe this was important. I don't know, and you're kind of relying on the LLMs to be like very, very good at handling those kind of things.
Right. But the problem there is it's not efficient. You're passing in tokens that aren't necessary, and at every iteration, the same tokens are being passed again.
Yeah, so it's adding up.
Yeah, it's like just appending stuff to a list and throwing it into the model call. And since agents now are very iterative, this is super costly. That was our biggest takeaway throughout this process, one of them.
It's fine. I didn't think about it like that, right? Because usually I think most people really just making sure that things will work.
Yeah.
And only way afterwards you're starting to look at maybe it takes too much time. And now, I think there's a lot of misconception that now that we have LLMs and those powerful tools, you don't really have to go really deep into it and read the data, or hopefully you don't want to do it.
Right.
But apparently there are things that you cannot do.
Yeah. And from my perspective, a lot of people are taking the same approaches to building agents, and these approaches are naive, like the tool calling context engineering approach I mentioned. In order to really innovate, you have to sit down, read the agent traces it's redundant and horrible and painful, and you need to look at each point, each LLM call, and ask yourself, can I remove any information here? And then you build it into like some sort of algorithm to do so. And in my view, a huge challenge going forward into the next year and beyond is The time horizon of agents is increasing exponentially, as we agreed on earlier, which means in order to read an agent trace, it's becoming more and more painful. Imagine reading the agent trace for a 10-hour agent execution.
I think there's now agents who read other agents' traces.
So that's where I was going to go. It's a perfect task for an LLM because it's a huge volume of text, which LLMs can read very quickly. So I'm hoping that in the next year, there are models tuned specifically for reading agent traces and identifying potential failure modes, anomalies, so that you as the agent builder you know what you should be focused on, how to really productionize your agent.
Yeah, and then we'll see a lot of companies that say, can you trust these models?
Yeah.
Right? We will have models that will make those models reliable. Fun circle.
Yeah.
I think.
Yeah.
So you think this is the future of I kind of tend to agree. It seems like a no-brainer for that.
Like what I believe is that the next development will solve the current pain point. And building agents right now, the biggest pain point, arguably, is reading the agent traces and making sense of them. So I assume that pain point will be solved in the near future. If you were to ask me 7 months ago what the biggest pain point is, I would have said the model's ability to perform tool calling effectively. And since then, all the models have been fine-tuned for tool calling.
Yeah.
So the innovation over the last 7 months solved the pain point of that time. And they can go further. Like the tool calling performance will continue to improve over time. But I think this idea of like understanding the agent trace is a huge current pain point.
You got me convinced. So hopefully anybody listening can build this tool to help us in the next 7 months. So this is the future of the, let's say, industry. What would you say the future is for Tavily?
So right now, we are focused on delivering search to enterprises or web connectivity. And it comes in a variety of different forms. A lot of customers want to build their own agents with our set of tools, like our search, extract, crawl, and map tools. And others want to consume more out-of-the-box, like research agents. So we're focused both on the agent building, like the research agent, improving that, and also improving our core infrastructure. So our search, our scraping, our crawling. And we have made significant advancements in the last couple months. Our goal is to provide context engineering out of the box under the API, essentially. Whether you're using the research endpoint or search, search results should not provide noisy tokens to the model. We understand the importance of what information and the quality of data that we're returning from search. So we're focused on doing context engineering on our side so that the data we provide back to the end user is high quality and token efficient. So improving this, like working on our infrastructure and improving this context engineering that we're handling is super important. Also different flavors of search. So faster search, deeper search.
It seems that you want to use your experience as like builders who use the search API to improve your own search API and do the work for all other builders out there.
Yeah, exactly. And building this sort of a web infrastructure is a huge headache. And developer teams don't want to deal with it. So we're taking on the headache. And not only are we building search, but we're building it for the end user of an agent or a model. And what that means is we're going to do context engineering on our side so we can provide the most relevant data and only the most relevant data at low latency.
Cool. Sounds interesting. I'm here for it.
Yeah, it's quite the challenge, but we're moving along in the right direction.
Great. Thank you so much, Dean. It was such a pleasure having you here.
Of course, yeah. Thank you for having me. This was a lot of fun.
And for the rest of you, stay tuned for other episodes of YAAP.